Yo, Smart Rover. I am Sarthak Bauddha, and this is my innovative rover built from old IC car parts. It moves like a chant and trap stuff. Check it out.
Take seven.
Today I will show you how it works, how I built it, and put it through its paces. Let's dive in. Why I built a rover? I wanted a rover that could handle tough terrain like my backyard, rocks and bumps, while being able to pick up small objects and avoid obstacles. The goal was to create a versatile, remote control bot with a sleek design and smart features. It's a challenge that combines mechanics, electronics, and coding, and I'm excited to share the journey with you. Here is what I used to build this robot: a hot chassis to hold everything together, then servo motor for the arm, a BLDC motor connected to pin 25 for propulsion, 2DC motor driven by an 8 to 9 3D chip for reverse movement, one ultrasonic sensor behind for distance measurement, two wire sensors, each side detection, and bullet display for real-time feedback. An ESP32 developer module as the brain, handling Wi-Fi and PWM signals. A 5-volt power supply for servos. The build process took 2 months. I started with the chassis, mounted the servo for the arm, and wired the BLDC motor to the ASC. The sensor and OLED were soldered to ESP32, and I added a capacitor to keep the servo steady. Coding was the fun part. Let's talk about that next. So, how does the innovative rover tick? Let's geek out. The ESP32 runs a web server, letting me control the rover via a browser. The interface has sliders for servos, buttons for the BLDC motor, power backward stop, and a speed slider. The servos handle movement and wrapping. Each uses a dedicated PWM channel on the ESP32, like Servo 6 and 7 on pin 50 and 80. I coded a smoothing algorithm to move them in 1 degree step every 15 milliseconds, so they are super steady, no jitter. The BLDC motor on pin 25 powers the back wheels. It's controlled with PWM signals 1 millisecond to 2 milliseconds for forward. The ESC needs 3-second armic sequence to start. Ultrasonic sensors measure distance to avoid walls while moving in reverse. Fire sensor detect obstacles and drop the data on the OLED display for real-time feedback. A DC motor had an extra drive control via the L29 3D chip. I was not all smooth sailing. The BLDC motor was tricky. The DSC needed precise PWM tuning and getting the web interface to work reliably took some devoting. Each challenge made the rover better. I have placed two servos at the middle so that it can fold and increase its down clearance as needed, and it can go through obstacles. Time to see the rover side. It climbs, dodges, and traps with ease. Check out telescope trap and those steady attacks. That is the innovative rover, and I am stoked with how it turned out.